Okay, in this video we're going to be looking at solving linear equations that involve fractions. So in our first example we've got half x equals 3. Now we've got to remember in here we have our invisible times sign. So we can rewrite this side as a half times x equals 3. Now a half times x, we can turn our x into a fraction, and that would just simply be x divided by 1. Now, we know when we're multiplying fractions that we multiply the top by the top and the bottom by the bottom. So, on the top we have 1 times x, which is x. And on the bottom, for our denominator, we have 2 times 1, which is just 2. So that's how we get from a half x to x over 2. And then that equals 3. So now we're ready to solve it. Now, at the moment, we've got x divided by 2. Because we're dividing by 2 and we want to get x on its own, we need to do the inverse of dividing by 2. So the inverse of divide by 2 is just times by 2. And we're going to do that to both sides to keep the equation balanced. So I'm going to write this out. We've got 2 times, and then we've got our x over 2. And then on this side, we've got 3 times 2. Now, we know that if we've got 2 and we're multiplying by 2 and then we're also dividing by 2, those two things cancel out and that will give us 1. So that gives us our singular x. And then 3 times 2 is 6. So that is our solution, x equals 6. Now, there's another way we can write this out, and that's to use our triangle. And we call this a rearranging triangle. Okay, now it's important to look at our original equation, and we've got half x equals 3. The number on the top, as once we'd rearranged it, we got x. So that's the number in the numerator of the fraction. So we're going to stick that in here. And then the number on the denominator was 2. And the equals was 3. So that was on that side. So this triangle, we can change bits of it. We know that this line here means times, and this line means divide. So that means that x divided by 2 equals 3. And also, if we want to look for our x on its own, it's just going to be 2 times 3. So I can rewrite that as x equals 2 times 3. So we go back to our x equals 6. And that was what we got when we solved it more algebraically. Now, if we come over to this example, we can see that we have x over 3 minus 4 equals 12. What is our x over 3? Well, that is just going to be a third x because this is going to be 1x on the top. So that's a third times x. And then we're taking away 4 and we're getting 12. So the first thing we need to get rid of is that minus 4. How do we get rid of minus 4? We're going to add it to both sides. So add 4 and add 4. So on this side, we're going to have x over 3 minus 4 plus 4 equals 12 plus 4. So we know that minus 4 and plus 4 gives us 0. So we're just going to be left with x over 3 on this side. And that equals 12 plus 4, which is 16. Now what we need to do is, because we're dividing by 3, we want to get rid of divide by 3. So how do we get rid of divide by 3? Times by 3, because that's the inverse. And we do that to both sides to keep our equation balanced. So I can rewrite that as 3 times x over 3 equals 16 times 3. And now I know that the 3 times and the divide by 3 cancel each other out to give me 1. So I'm left with x on this side. And 16 times 3 is 48. So that is going to be my solution. Now if I think about putting that into the triangle. Oops. Then I've got the X on the top. I'm going to put this one into the triangle, sorry. So I've got the X on the top, I've got divide by 3, and I've got the 16 over here. So again, if I just cover up the one I want, I get X equals 3 times 16. So X equals 48. And there we have our second solution.
Okay, Marie, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.